Algebra 2B, it is Friday and we are working on our last lesson, Notes Day 5, sigma notation. Okay, the Greek letter sigma means sum, or to add up. So if you look at the sigma you have here, it means substitute values 1 through 6 into the formula for n, and then add up all those values. So n equals 1 is the first one you're supposed to plug in, and n equals 6 is the last one. And you're supposed to take those numbers and plug it in for n, and then add them all up. So the sigma notation says to take all those numbers from that sequence and then add them up. So let's look at example 1. We're going to add up the numbers in the sequence from 1 all the way to 15 in the sequence 2n plus 5. So what we need to do is figure out, is it arithmetic or geometric, so we can figure out which formula to use. It is arithmetic because there's no exponent. Look at the form. It's going to be the form of an arithmetic sequence. So what I need is I need a sub 1, I need a sub 15, and I need the number of terms so I can plug it into my formula. So I'm going to plug 1 into a sub 1 for n, so 2 times 1 plus 5. That gives me 7. I'm going to plug 15 in. That gives me 35. And now, it looks simple, there's going to be 15 terms, but what I want you to remember is that it might not always start at 1. So what you're going to do is you're going to take the top number, subtract the bottom number, which gives you 14, and then add 1. So that's going to give us 15. Okay, and you'll see there are examples where it does not always start at 1. So now we have all that information. Let's plug it into the formula. S sub 15, 15 over 2, plug 15 in for n, add up 7 and 35. If you do that calculation, you should get 315. Let's go down to number 2. Okay, again, this is arithmetic, so now we can use our arithmetic formula. We're using our arithmetic sum formula because there's no exponents. So I need my a sub 1, I need my a sub 20, it's going to 20 here, and I need my n. A sub 1, I'm just going to plug 1 in for n. So I get 5 halves in fraction form. A sub 20, 1 times 20 plus 2. That comes out to be 12. So I have my first term, my last term, and the number of terms, I'm going to take the top number, subtract the bottom number, so 20 minus 19, and then add 1, which gives me 20. So now I can plug it into the formula. S sub 20, so the sum of those 20 numbers, 20 over 2, add 5 halves plus 12. If you add all those up and do the calculation, you get 145. Now let's look at 3. Number 3 is a little tricky one. The reason being is, look at the lower and upper number. This is an example. It doesn't start at 1, so we're not going to have 12 terms here. Okay? The next thing we got to figure out, is it arithmetic or geometric? Well, it's going to be geometric because look at the formula. It looks just like the geometric formula. So now what I'm going to do is, I need my constant ratio, because here's the formula. S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. So I need that constant ratio, and I need the number of terms in the first term. So let's calculate that first term, which is a sub 3. That's the lower number right here. So I'm going to plug that in. 2 times 3, 3 minus 1. That comes out to 18. Think of the formula here. Okay? This would be the first term if we started at 1, but since we start at 3, we got to find that third term. Next, here's our constant ratio. Here's our r. So we have the constant ratio, we have the first term in this sequence that we're trying to add up. How many terms is it? You got to take 12 minus 3 and then add 1. So 12 minus 3 is 9. Add 1, which is 10. And now we can plug it in the formula. So I have S sub 10 equals a sub 1, in this case, which is the first term of what we're adding up, is 18. 1 minus the constant ratio, which is 3. And n, which is the number of terms, is 10, all over 1 minus 3. If you do this calculation, you should get 5, 3, 1, 4, 3, 2. So 531,432. That's a hard one there. We got to figure out, is it arithmetic, geometric? Got to figure out what is the first term of the series that we're adding up, and you got to figure out how many terms there are there. Okay, let's go to number 4. This is going to be geometric as well. Okay, because of the form that it's in. It goes from 1 to 12, so we know the number of terms is going to be 12. 12 minus 1 is 11. Add 1, you get back to 12. But we need this first term, so a sub 1. That comes out to be negative 2. So now we have the first term, we have the number of terms, and here's our r, negative 2. So let's plug it into the formula. S sub 12 equals negative 2. 1 minus, in parentheses, negative 2 to the 12th, all over 1 minus a negative 2. So the next step, I get negative 2, 1 minus 4096 over 3. And we get S sub 12 equals 2,730. Okay, we got one more. Example 5. Example 5 is from 1 to 86. This is the reason why we use this summation. You're not going to want to add up every term from 1 to 86. But it is going to be arithmetic, so we can go back to that first formula because there's no exponent there. So we need the first term. We need the 86th term. And we need the number of terms. First term, plug it in. Plug 1 in for n. You get negative 5. The 86th term, or the last term, plug 86 in for n, and you get negative 175. And the number of terms, take the top, subtract the bottom, 86 minus 1, and then add 1, so 86. And now we can plug it in. The sum of those 86 numbers is 86 over 2, negative 5 plus a negative 175. So if you do that calculation, you should get negative 7,740. Okay guys, so you've seen 3 arithmetic and 2 geometric. So look back to those for examples. Here's the textbook assignment. Please get started.